Alright, I want to just give a couple examples of how to set up simple harmonic motion functions. And here I'm basically just going to show you how to get the graph of what the function looks like, and from there you can go watch a different video on how to actually determine the equation of the graph. And so what you'd want to look for is determining the equation of a trig function given the graph. Okay, so what is simple harmonic motion? A few examples here are basically if you imagine here's some board or something and you have a spring hanging from it that is that a weight is attached to. So if it were sitting still, the spring would be stretched out, the weight would be hanging. But if, for example, you pulled down on this weight, right? If you pulled down on the weight, then it would look something like this. Something like that. And if you were to then let go, this weight would go up above its rest position, and it would come back down to this position. It would keep going up and down, up and down. So the height of this weight, or the length of the spring, would be oscillating, going back and forth forever, repeating its pattern over and over. And you could see that if you were to graph that, it might look something like a wave. Its height might look something like a wave, going below and back up and below and back up. So that's simple harmonic motion. Another example might be a pendulum. If you imagine a pendulum that is out here, and let's say its rest position is right here, so and you let the pendulum go, it would swing to the right through its rest position, and then it would swing back here, and it would keep going back and forth forever. And so the angle that is formed here with its rest position would be a graph just like this. Let's see, the angle, if it started out here, might be negative, the negative angle, and then it would go to 0, meaning it would be a 0-degree angle with its rest position, and then it would go up to this part, which is the same angle in the positive direction, so you'd have a positive angle, and then it would come back down to 0 as it swung back to the rest position, and then it would swing back to its initial position, which is the negative angle side. Okay, so those are a couple examples of harmonic motion. And so let's actually graph what one of these might look like. Let's take the pendulum example here. Let's say that the pendulum is 12 degrees from its rest position, and it's released at time t equals 0. So on our graph here, the x-axis is going to be our t-axis, or time, and our vertical axis is going to be degrees, the position of the pendulum at the given time. So at time 0, the pendulum is at negative 12 degrees, let's say. Let's say to the left is negative angles and to the right are positive angles. Okay, so at time t equals 0, the pendulum is at negative 12 on the degree axis. And let's say that if it's released and allowed to oscillate, to swing, then it takes, let's say, time to come back to this position is a quarter second. Okay, so it's swinging pretty fast. So that means it would go there and back in a quarter second. All right, so in 1/4 of a second, so time is in seconds here. So at time 0 it's at negative 12, and at time 1/4 it's at negative 12. Well, that would mean halfway through a quarter, it would be on the other side at positive 12. So half of a quarter is an eighth. So at an eighth of a second, it's at positive 12. And then, of course, halfway between 0 and an eighth, as it swings to the right, it would go through 0 degrees. So that would be a 16th, which is right here. So our graph would look something like this for one swing. And then as it comes back, it would swing through 0 again, between an eighth and a quarter, and we could label that as well. And so the graph of a single period would be this, and then we could try to set up the equation of this function, which would be something like y equals negative 12 cosine of some angle here, and we'd have to adjust the angle. It's negative 12 because it's reflected over the x-axis. It's cosine because it starts at a minimum, not at 0. And then you'd find the angle using methods described in another video.